scholars, remember, this is Mr. Intunza with you. No, you don't need to remember that. What I'm saying is, remember, I promised you a surprise, right? Well, surprise is right here. This crazy looking pyramid triangle, which is actually called Pascal's Triangle, is going to help us do the previous problem that we just did a lot faster. So let me show you how this, how they derive some of these numbers, and then what they mean to our binomial theorem for our specific binomial theorem application. Okay, so here we go. Well, if you would notice a Pascal triangle, obviously you see a bunch of ones towards the outside on both sides. So let's see where these numbers on the inside come from, or how this works. So it starts off at the very top with a 1. Then you go with your ones on the sides right here. And then where you start seeing some changes here is on the third row. Notice you say 1, 2, 1. Well, how do you know this has to be a 2 there? Why is this not some other number? Well, because this 2 comes from 1 plus 1 is 2. Okay, so 1 plus 1 is 2. That's where this one came from, right? And then you close it off, 1. Well, if you want the next row, it's also the same thing. 1 starts with a 1, and then they go to 3, 3, and 1. And you're thinking, well, wait a minute, why is this a 3 now? Well, check this out. 1 plus 2 is 3. 2 plus 1 is 3. And guess what? Well, as you move down the rows, that pattern continues throughout. So you started off with a 1, and then look. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And basically, if you check throughout, it just always works out that way throughout. Okay, so what I want you guys to do right now is pause the video, copy this down, and then we're going to discuss a little further how it applies. All right, now let's go ahead and continue, and I'm going to tell you how we're going to use this for the binomial theorem. First of all, when we do the binomial theorem, what happens is that actually these rows of numbers are actually the coefficients of the terms that you're expanding, of the binomials you're expanding. What I mean is this. If you're going to expand x plus y to the 0 power, isn't that simply just 1 and nothing changes, right? So this right here is your x plus y to the 0 power. Well, if you're going to do x plus y to the first power, these are your coefficients. Think about it. If you have x plus y to the first power, can you do anything? Are you going to multiply by anything? No, you're done, right? Wouldn't it just be x plus y? Well, what's your coefficient of x? Well, 1. What's your coefficient of y, or the number in front? Well, 1. There you go, right? Well, guess what this one is then? If this is x plus y to the 0, this one is x plus y to the first, what do you think this one is? You're right. It's going to be x plus y to the second. So that means that if you want to expand this specific one, your coefficients are going to be, for your first term is going to be 1, the coefficient for the second term is going to be 2, and for the last term is going to be 1 again. Now, the example we just did, do you guys remember the coefficients from the previous example? Weren't they 1, 3, 3, and 1? Well, you could use this now to actually find those coefficients. This is x plus y to the third. So this triangle would actually give you the coefficients depending on the exponent of your binomial. So let me show you the rest of them. Obviously you can follow the same pattern. So then the next one is x plus y to the fourth. So if I wanted to expand this, I know the coefficients already. 1, 4, 6, 4, and 1. And then you can just write them down by using your triangle. Okay, so this triangle, Pascal's triangle, will save you tons and tons of work. So you are welcome to derive it if you need it when you're taking the exam, or if you ever need to use it for this, you're welcome to derive it instead of using all the other, the n choose r. Okay, instead of doing that, you could use this just to simply set up your coefficients. There's nothing wrong with that. So what I'm going to do right now, guys, is I'm going to go through and actually do the problem that we did before, but doing this, and you'll see how much quicker it is. So follow me over here, please. The problem was x plus 1 to the third power, right? Now, we spent a lot of time finding our coefficients, right, by using n choose r, right? Or so what we're going to do now, I'm just going to look at Pascal's triangle, write down my coefficients, and then just follow the pattern that we discussed with the first term and the second term, and you'll see that it's a lot quicker. Check this out. So, I'm looking for x plus 1 to the third power. So I look at Pascal's triangle. Oh, my coefficients must be 1, 3, 3, and 1. Oh, okay, cool. 1, 3, 3, and 1. There's my coefficients. Done. Doesn't that beat doing n choose r for every single term? Oh, yeah. And you can imagine how much worse it is if this were, for example, a 5, a 6, a 7. Could you imagine doing n choose r for every single term? It would be a lot of work. So use a triangle as a tool to help you come up with these quickly. Now, let's follow the pattern. Remember, the term on the left, it's in descending order depending on the exponent. So starting with 3, this is going to be x to the third, x squared, x to the first. And remember, it's x to the 0. We don't write it because we know that x to the 0 is actually 1, right? So if you want to write it on there, it makes you feel better, you can go ahead and write it, but in the final answer, just go ahead and turn it into a 1 anyways. Okay? Now, and here we go. Here's my second term, right? My second term is going to be basically backwards, right? We're going to start instead of descending order, ascending order for the exponent. So this is a 1, so it's going to be 1 to the 0. But once again, any number to the 0 is always 1. So if it makes you feel good, go ahead and write it. But in the final answer, make sure that you simplify this into a 1. So myself, I'm just going to leave it like that. So 1 to the 0, 1 to the first, 1 to the second, and 1 to the third power, right? And so there's my answer. Look, my answer is 1 times x to the third is x to the third. Whatever this is, we're going to write it on here if it's a plus. If this is a minus, it's a little different, but we'll show you in an example right now. And this is going to be 3x squared plus 3x to the first plus simply 1. It's a lot quicker, trust me, to use your Pascal's triangle as a tool to help you find the coefficients. Then after that, all you have to do is just simply follow the binomial theorem, or basically just think of it as a pattern for now. And that will be it, guys.